Okay, and okay, so for helium atoms, what is the RMS speed at 295 Kelvin? So our RMS speed just comes from our relation that our average kinetic energy is 3/2 RT, but our average kinetic energy is, at least for a collection of similar masses, 1/2 mv squared, or where v here is our average speed, or our RMS speed. And so we can solve for our speed by rearranging this. These twos will cancel, and 3RT over m square root. Okay. So we have our temperature. This is our gas constant, which is 8.314 joules per mole Kelvin. I believe that's right. Yeah. Okay. That's our temperature given in the question as 295 Kelvin. And this is our mass of a helium atom. So our mass for a helium atom is our molar mass, which is 4.002902 grams per mole. But we need the mass of an atom, so that means that mass is our molar mass divided by our Avogadro's number, which is 1/6.022 times 10 to the 23. So that's 1 mole, and that's atoms. And so doing that multiplication, grams per mole, 1/6.022 times 10 to the 23 mole. So the moles cancel, and we get got carried away there. Since that's already in joules per mole Kelvin, we actually don't need to remove the mole. It's my mistake here. All right. But what we do need is, because joules are kilograms meters squared per second squared, we do need this in kilograms. So we need to use multiply by 1 kilogram per 1,000 grams. So the grams cancel. And then this is 4.02902 times 10 to the minus 3 kilograms per mole. Okay. And so using that mass and the other expressions, our RMS speed becomes square root 3, 8.314 kilograms meters squared per second squared mole Kelvin. T is 295 Kelvin. So our Kelvins cancel, and divided by our mass, which is 4.002902 times 10 to the minus 3 kilograms per mole. And extending that down into kind of a funny shaped square root. Kilograms cancel, moles cancel, so leaving us with meters squared per second squared, which when we square root will be meters per second, which is what we want, because that'll be a speed. So our average speed, running this all through a calculator, square root of 1.83 389 times 10 to the 6 meters squared per second squared, or our average speed is 1.36 times 10 to the 3 meters per second, just rounding at the very end. And if we go through the solution here, so again, so using everything in kilograms, putting everything through, doing the math, so 1355, so rounded to 1.36, and so that